So welcome to a short video on the historical and technical significance of Faraday's law and Lenz's law. This is just a little bit of information that relates to part of a unit that's studied on the Access to Science course and in the electromagnetism unit. Okay, so let's have a look. So Faraday's law, let's just remind ourselves what that was. I'm going to write it like this. Okay, so triangles mean delta, or rather as the Greek symbol delta, it just means a change, a small change. And E is the electromotive force, essentially just a voltage that's produced. N is the number of turns on a coil, and this symbol, a capital phi in this case, is to do with the magnetic flux produced by a magnetic field. Produced by a magnetic field? Produced by a magnet. Okay, and so it sort of gives us an indication of the strength of the magnetic field. And so we find that these numbers on top tell us that if we have more coils or a stronger magnetic field, we're going to produce a bigger voltage. And the T at the bottom is to do with the change that's taking place. Faraday's law says that it's proportional to the rate of change of these things. So if we change this quickly, this is a small number. And so a small number on the bottom of a fraction means that we have a big voltage produced. So the faster we spin our generators, the greater the voltage is produced. Okay, so that's Faraday's law. And Lenz's law, if we look at the maths of it, is cheekily a minus sign in there. Okay, and Lenz's law, if you may remember, is that the induced current produced by this effect acts in such a direction that it opposes the change causing it, linked to the principle of conservation of energy. All right, this is linking the fact that we can turn kinetic energy into electrical energy. It's one way of thinking of it. Okay, so that's Lenz's law and Faraday's law. So just very quickly, historical and technical significance of it is essentially, we're kind of give Faraday a bit of a credit for this one, but basically Faraday, and I think essentially something like 1831, he produced the first electric generator. Okay, so whether it's 1831, he came up with his law, which helped him. He was very much a practical guy. He wasn't just pure mathematician. He was very much a practical guy. Didn't get bogged down by the maths, but observed principles and used them. And I think it was about what are we looking at? 1834. We get Lenz's law. So whether Faraday came up with his law, I'm not sure. But basically, this is a kind of the period of when these guys did it. So Lenz, I believe, was a German. Faraday was, I think, he was a northerner. So he's from Yorkshire, possibly Cumbria. Not sure where the boundaries lay at that time. And the significance, the historical significance is before this, we did have electricity. Faraday himself made sort of batteries. We could make batteries. And but we weren't able to sort of produce a continuous supply of electricity. And again, people have improved Faraday's generator in many ways, but without his first generator, we wouldn't have electricity being supplied to our homes in the way that we have. Industry would not have a continuous electricity supply. So the majority of electrical generators, the majority of where we get electricity from to charge up our own batteries, our own rechargeable batteries, comes from understanding about Faraday's law and Lenz's law and how we generate electricity from that motion of a coil or a conductor moving in a magnetic field. So that's the technical significance of is the generators, and before that we wouldn't have that. Okay, and obviously it took a bit of time before we get that the system we have, the national grid in the United Kingdom that we have at the minute, and but most generators, most ways of generating, whether it's through hydroelectric, whether it's through burning coal to generate steam to force it through a turbine, bolted onto a generator to create electricity, or whether it's done through heating that water through nuclear energy, nuclear power, whether it's a wind turbine, whether it's a gas turbine, it's all done using a generator, and we have to give Faraday a little bit of credit for that. And Lenz even for helping us understand a few of those aspects. So that's the historical and technical significance of Faraday's law and Lenz's law. Before understanding these things, we wouldn't have generators, we wouldn't have electricity in the way that we have all over the place. A very convenient way of generating energy and supplying it to our homes and businesses. Okay.